Hello, welcome back to another lesson with me. Today we'll talk about exponent. Let us consider these two questions. You may want to stop the video and attempt this question before you press play. Alright, welcome back. So what does a to the power of 3 divided by a squared means? Well, I can just do the obvious, that is a to the power of cube is a times a times a divided by a times a. And if you do cancellation, then you see that the answer is just a. And observe, this is the same as a to the power of 1. Okay, so what observation can I make? Well, I can see that at the moment, a to the power of cube divided by a squared is actually equal to a to the power of 1. Then I can ask myself, well, how does the index 3 and 2 is related to 1? Okay, how about 3 minus 2? Well, that's equal to 1. So that is my observation. So at the moment, I could conjecture, that is, I make a guess that if I have a to the power of 5, let's say, divided by a to the power of cube, then the answer should be about index 5 minus 3 or a to the power of 2. That's my guess. Well, let's try it out. A to the power of 5 is a times a times a times a 5 times divided by a cube, a times itself 3 times. And by cancellation, you will see that the answer is just a squared. That's exactly what we have. Okay, welcome back. Let's try this out. A to the power of 6, this is just basically a raised a, and then we take the difference of the indices, 6 minus 2, so that is a to the power of 4. This one is the same as a to the power of 7 divided by a to the power of 5. And taking the difference of the indices, that is a, 7 minus 5, we end up with the answer a squared. Over here, we need to separate the numbers and the indices. Divided by 10 to the power of 8. So here the answer is 6.022, and this stage is 23 minus 8, 10. And make sure the index is written smaller than the number, the base. Okay, 23 minus 8. So we have 6.022 times 10 to the power of 15, for example. And the last one is similarly 022 divided by 2 times 10 to the power of 23 divided by 10 to the power of 20. So that will be 3.011 times 10 to the power of 23 minus 20, or 3.011 times 10 to the power of 3. By the way, an extra bonus question. Does anybody realize what this number stands for? 6.022 times 10 to the power of 23? If not, please ask your chemistry teacher. Now, you should be able to summarize our previous lessons using this particular notation, a to the power of m divided by a to the power of n. What is that going to be? Well, hopefully, you're going to write this as a to the power of m minus n. That is the difference of the indices. The first one, the first index minus the second index. So if you have a to the power of n divided by a to the power of m, then that will be a to the power of, very good, n minus m. Still the first index minus the second index. Now at this point, you probably will be wondering, what does it mean to have a to the power of m divided by a to the power of m? Before we answer this question, maybe it's good to consider this particular example, a cubed divided by a cubed. So what does that mean? Well, a cubed means a times a times a is by itself 3 times, and the denominator similarly. So if you use cancellation, you will find that, well, all the numerator cancel, all the things in the numerator cancel with every single item in the denominator. So in this case, we get 1. And also from this rule above, if we treat 3 as m, the second 3 as n, then I would have this, that is 3 minus 3 in the indices. And that will become, the difference of that will be just simply 0. So now I'll make an observation that probably a to the power of 0 is equal to 1. Alright? A to the power of 0 is equal to 1. I can do another check. How about a squared divided by a squared? Well, that would be a times a divided by a times a. And by cancellation, you will see that this is also equal to 1. Therefore, it must be the case that a to the power of 0 now is defined as 1. So at this stage, we can make another summary. That is, if you have a to the power of m divided by a to the power of m, then this is a to the power of 0. And that is equal to 1. Alright, so far so good. Now, there is a qualification for this. A to the power of 0 is only equal to 1 as long as a is not equal to 0. This is a qualification that you need to remember. So then, a bonus question for you to think about is, why is 0 to the power of 0 not equal to 1? Thank you very much, and I hope you have enjoyed the class. Bye-bye.